let's see if we can tackle this problem. This is a first order linear differential equation. So what we want to do is write it in standard form by dividing by 1 plus x. So we have dy dx minus x divided by 1 plus x times y is equal to, now this has an x factor out that you can take out, and then if you take that out you get 1 plus x divided by 1 plus x. Well, that will just leave x. So if you remember our formula, the technique that we will use if we have a first order linear differential equation is that we will find an integrating factor. We'll call it mu, and we need to somehow find the integral of the p term, and the p term in this case is negative x over 1 plus x dx. Alright, so what we'll do is we'll first compute this mu, and then we'll multiply it out. Actually, before we compute the mu, let's just focus on this integral here, and then we'll put it as a power of e, and then we'll go from there. So we need the integral of a negative x over 1 plus x dx, and we'll need to use a U-substitution here. This is one of those tricky substitutions where the u is just going to be, the du is just going to be the dx, but the more important part is to get rid of that x up on top, so we know that x is equal to u minus 1. So we have, let's put the negative outside, u minus 1 divided by u du, and here we have 1 minus 1 over u, and then we take the integral of that. This is u minus ln of u, and now let's just distribute this negative sign so we don't have to worry about it. We have a minus x plus 1 plus ln of x plus 1. Now there's a couple things to note here, and one of them is there's a plus c. Now if you distribute this, you get a constant in the mix, and that constant can just kind of merge with this constant. So just for ease sake, or to make things easier, let's merge that with this constant, which we know that we can ignore because we're going to take another integral and find that constant. So what does that mean? That means that we can now find our integrating factor. If we put this as a power of e, this is negative x plus ln of x plus 1, and when we work that out, this is e to the negative x times e to the ln of x plus 1. Okay, that is our integrating factor. Now that we have that as our integrating factor, we can skip a few steps because we already know that when we multiply by the integrating factor, the right hand side will be a perfect product from a product rule, and then so what we have left is the integrating factor, e to the minus x plus 1 times y. This is the resulting product, so that when we take the product rule we get that, and then on the right hand side we have x e to the minus x plus 1, and we undo the product rule, which means we had taken the derivative, or the antiderivative, and now we have this, which is an integration by parts problem. So let's try to do that integration by parts problem somewhere over here maybe. This is e to the negative x, and this is x squared plus x, it turns out. And we're multiplying that polynomial, and when we do that, I don't know if you've seen that technique where we have u's and v's and stuff. if we let u equal to the polynomial and dv equal to the exponential function, here we'll take a series of derivatives. This is x squared plus x. The derivative is 2x plus 1, and then the derivative is 2, and then eventually 0. Here we're going to continue to take antiderivatives, e to the negative x with a negative 1, and then take the antiderivative again, e to the negative x, and etc. So there's like a pattern here where you take the products of these diagonals. So anyways, you can do integration by parts a couple of times if you want to make sure that this is correct. I'll go with this, and I'll just say that this antiderivative turns out to be x squared plus x times negative e to the negative x, let's put parentheses there, plus, or this is a minus, and then here we have 2x plus 1 times positive e to the negative x, and then this is a plus, alternating sign. We have a 2 times negative e to the negative x, and then everything else is 0, so let's put a plus c here. And then if we simplify this, we have a few e to the negative x's. That's in common with everything except for the c, so let's keep the c out of this. And then what we have left is a polynomial. We have a negative x squared, and if we gather the x's together, that's an x with a negative, this is a 2x with a negative, and that's it, so it's minus 3x. And then the constant, this is a negative 1 and a negative 2, so let's call it negative 3. So that's our right hand side, and now we continue and solve for the left hand side, solve for y on the left hand side, so we have y as a function of x. And then we can now divide out this e to the negative x, so that's gone, and then we have, let's see, minus x squared minus 3x minus 3 divided by x plus 1, and then the c is the one that is going to take on all this other stuff. So we have a constant c times, let's put e to the x on top as we divide it over, and then the x plus 1 goes down in the denominator, and that's it. So this is your solution for this differential equation.